All right, this is going to be number 22. I drew the graph on the board here so we can talk about all these problems together. Let's do number 22 right now. So it's asking from the figure above, this titration is, and it's going to give you a bunch of different things here. What I do is I go ahead and find the equivalence point. It's going to be the most vertical part right in the middle, and they usually kind of like make it kind of obvious for us. So I'm going to draw a line over to the pH, and I'm going to say that the pH, the equivalence point is above 7. It's above the midpoint. If I'm going to say that this the equivalence point, the median, the midpoint of this titration is above 7, that means I'm going to be thinking I have a stronger base. I'm going to be thinking I have a stronger base than a strong acid. And I'll show you why right here. So when I look at this titration, I think of a tug of war. And this tug of war is always happening. I'm sure everyone's played tug of war in the grade school. You know, they had a track and field or something. So what they do is they have people on this side and people on this side. And we're going to say they're both equal right now, just for science. And they have this rope that they're pulling across. And what they do is they start you right in the middle, always. And then they have you pull each way. One's going this way, one's going this way. If I have a strong acid and a strong base, pH 1 a strong acid, pH 14 strong base, and they're both going to pull equally because they're both equally as strong, then my pH is going to be 7 at the equivalence point. Now, let's redraw this thinking that we don't have a strong acid, strong base. Let's draw this as a strong acid, weak base. So if I'm going to do that, my midpoint cannot be in the middle because my strong acid, or my strong base will still be 14, fine. But my weak acid will not be 1. This is a strong acid. My weak acid is probably up here, like between 4 or 5 pH. So this is where I start. Where's the midpoint in this tug of war? It's going to be right about here. Midpoint here is about 8 to 9 pH. So if I say that, and I have a strong base, weak acid tug of war, I know my equivalence point will always be in the basic side because my strong base will always win. Let's try that again with a weak base, strong acid. So let's put our guys here. Let's put a strong acid and a weak base. Let's make our weak base 9 pH. And our strong acid will be 1. And we're going to put our tug of war again. And we're going to put our midline where we start out. This midline here is going to be about 4 to 5 pH. So if I have a strong acid, weak base tug of war, my equivalence point is going to be more acidic. So with what we just learned, let's go ahead and talk about where this falls here. This equivalence point is in the basic range. It's not at pH 7, it's in the basic range. So my tug of war means I'm actually doing this. My tug of war means I actually have this. And my pH is right about there. There's my tug of war. There's my equivalence point. That's right here. So I know I have a strong base, weak acid. Which one of these has strong weak acid? That's letter C. So we know our answer should be C. Let's go ahead and talk about number 23. 23 is asking what volume of titrate is required to reach the equivalence point. This is the equivalence point right here. But to solve that, go straight down. You should see that it hits about 100. So we're going to say 100 milliliters is required to reach the equivalence point. So let's go ahead and talk about what this is pH at the equivalence point. We're going to say between 8 and 10. Let's make that 9. Excuse me. So that was number 24. We said our pH is 9 at the equivalence point. What is the number 25? What is the difference between the equivalence point and the end point of a titration? Well, the equivalence point is when you have equal amount of moles of base and acid in the solution. It doesn't mean that there's the same strength. It just means you have the equal amount of moles. When you have a end of titration, that means you only have one set of the solution in there, and the other solution has been completely washed away by the other solution. So up here, we have very, very little acid left. We're at pH 12. We washed all the acid away. We started off with a pH 3. We started adding base until we actually have no acid left. So at our pH, at our equivalence point here is equal amount of moles of base and acid. Up here is we have no more acid left. That's number 25.